This short presentation will describe service calculations for single-family dwellings, as described in the Canadian Electrical Code, version 2015. For this example, we will use the following information to calculate the minimum standard rated service size. The house will be a two-story, two-car garage, electrically heated single dwelling with the dimensions of 12 meters by 10 meters for both floors and a basement area of 89 meters. This calculation will also assume the system is a 120 240 volt single-phase system. The following loads will be used to calculate the size of the service. A central electric furnace, 20 kilowatts. 6 1000 watt baseboard heaters. A range of 14.5 kilowatts. One 4 kilowatt clothes dryer. One 1500 watt microwave oven. One 3500 watt hot water tank. Two 120 volt receptacles in the garage for an electric vehicle. Rule 8-110 calculates the total living area of the single-family dwelling in square meters. The living area designated in Rules 8-200 and 8-202 shall be determined from inside dimensions and include the sum of 100% of the area on the ground floor, 100% of any area used for living purposes on the upper floor, and 75% of the basement area. The first floor area, given as 12 by 10 meters, calculates to 120 square meters. At 100% is 120 meters. The second floor area, the same as the first floor area, also calculates at 120 square meters. The basement area, given as 89 square meters, is calculated at 75% of the area, giving 66.75 square meters. The total area is calculated by summing up the previous numbers, 120 plus 120 plus 66.75, giving a total of 306.75 square meters. Rules 8-200 1A1 and 8-200 1A2 are used to calculate the total service load of the living area. Use 5,000 watts for the first 90 square meters or less of living area, plus an additional 1,000 watts for each 90 square meters or portion thereof of the remaining living area. In this example, the first 90 square meters of area calculates at 5,000 watts, the second 90 square meters of area, an additional 1,000 watts, the third 90 square meters of living area, an additional 1,000 watts, and the balance of the living area, 1,000 watts. Rules 8-200 1A3 and 62116 are used to calculate the electric space heating loads using the demand factors. For other than electric thermal storage heating systems, duct heaters, or electric furnaces, the demand factors are the first 10 kilowatts at 100%, plus any amount over 10 kilowatts at 75%. This will be the calculation for our baseboard heaters using Rules 62-116. For electric thermal storage heating systems, duct heaters, or electric furnaces, the demand factors are 100% of the load. Our 17 kilowatt electric furnace has a demand of 17,000 watts. Rule 8-201A3 is used to calculate the air conditioning loads at 100% demand factor. Our calculation does not have an air conditioner. Rule 8-201A4 is used to calculate the load required for each electric range by using 6,000 watts for ranges up to 12 kilowatts plus any amount over 12 kilowatts at 40% demand factor. Our calculation of the first 12 kilowatts of the range at 6,000 watts with the remaining 2.5 kilowatts at 40%, leaving a total of 7,000 watt demand factor for our range. Rule 8-201A5 is used to calculate the load required for any electric tankless water heater, water heaters for steamers, swimming pools, spas, or hot tubs with a demand of 100%. Our calculation does not include any of these loads. Rule 8-201A6 is used to calculate the total load for any electric vehicle charging equipment at 100% of its demand factor using Rule 86-306. Our two 20-amp receptacles with a load calculated at 20 amps times 120 volts at two receptacles gives us a total demand of 4,800 watts. Rule 8-201A7 is used to calculate the total other loads where an electric range has been provided for in Step 6 for the remaining loads in excess of 1,500 watts at a 25% demand factor for each load, or where an electric range has not been provided for in Step 6 at 100% of the rating of each load in excess of 1,500 watts up to a total of 6,000 watts plus 25% of each load in excess of 6,000 watts. Our house contains an electric range, so we'll be using 4,000 watts at 25%, giving a demand of 1,000 watts, and 25% of the 3,500 watts electric water heater with a total demand of 785 watts. Next, we calculate the total single dwelling load in watts by adding together the loads from all the previous steps. $5,000 for the first 90 square meter basic load, $1,000 for the second 90 square meter basic load, $1,000 for the third 90 square meter basic load, $1,000 for the fourth or balance 90 square meter basic load, $6,000 for the baseboard heater, $17,000 for the electric furnace, $7,000 for the range, 4,800 watts for the car receptacle, 1,000 watts for the dryer, and 785 watts for the hot water tank. This gives us a total of 44,585 watts. Next, we'll calculate the minimum ampere rating of the single-family dwelling service or feeder equipment by dividing the calculated single dwelling load in watts by the line-to-line voltage of the single dwelling. 44,585 watts divided by our 240 volt line voltage gives us a total of 185.77 amps for our service. Next, we'll determine the standard rated service or feeder equipment as follows. If the minimum calculated ampere rating of the service or feeder equipment is 60 amps or less, the minimum ampere rating will be 60 amps. If the minimum calculated ampere rating of the service or feeder equipment is over 60 amps but does not exceed 100 amps, the minimum ampere rating is 100 amps. If the minimum calculated ampere rating of the service or feeder equipment is over 100 amps, the minimum ampere rating is equal to or greater than the value calculated. Our service size is 189 amps. The panel size will be 200 amps minimum. The next section will calculate the size of the range feeder using section 8-300, range breaker size using table 13 and rule 26-712, the size of the main breaker using table 13, the minimum number of spaces in the panel using 8-110, service feeder sizes using table 2, size of the conduit for feeders, table 6, size of the service ground conductors, section 10, and the spacing of ground rods or ground plate depth using section 10.